All right, so let's start building a simple scene. I'm just going to use code to start, and then we'll also look at how to do stuff in the editor. So I'm going to remove my box. So I'm just going to delete all of this stuff. And so we have our basic setup here. So let's put a little comment up here that says setup. We have our scene, our camera. We have our renderer. Let's make this a bit smaller. And then we have our controls. Then of course we have the animate function, and we call animate here. So let's set up the rest of our scene now. The order of this doesn't really matter. There's different ways that you could structure it. I'm going to do it before my animate function. So I'm just gonna put animation here, and I'm gonna leave this animate call down here. So that's the last thing that will happen. So let's set up our scene. I'm just gonna make like a simple kind of like street block. So I'll make some buildings, I'll make a little road and a sidewalk maybe, and maybe some trees just to start out. And one of the things I want to point to is that when we're building a scene, if we have a lot of objects, we're gonna want to use some loops and some functions and stuff like that to make it a little bit simpler, because we are gonna wanna repeat our geometries a lot, just like we would if we were in P5 and we were making lots of rectangles and ellipses and things like that. So you guys can make a composition or scene of whatever you want, so you don't necessarily have to stick with exactly what I'm doing. So I'm gonna start with just like a street. And you could use a box for this, because one thing that happens with a plane is that it doesn't render the bottom of the plane. So if you can move the camera around and you can see below the plane, that ends up being kind of a problem, but we can make it double-sided. And since the geometry is simpler, I do want to use a plane just to make it so that my renderer doesn't have to do too much. And so if I go into the documentation and type in plane, we can see a plane geometry. And so you can see the plane here, and this is interactive. So you can kind of see this is the width and the height. And there's also the number of segments, so you can divide the plane into different segments. We don't really need multiple segments, so we're just gonna leave that part as it is. And so here's an example of the code, and then here is the actual constructor. So there's a width, a height, and then we can leave the segments. You can see that those are optional, so we're not gonna do those. You can see that we're going to end up using geometry and material a lot. So we want to kind of not have to like create these variables over and over and over again. So we'll try to give them different names or try to simplify them when we can. So let's start with this. So we have, this is going to be like the street. And so we'll start with our plane geometry. So I'm going to use an abbreviation here. I'm going to say street geo for geometry. And that's a new 3.plane geometry. And so for the width, this is where working in 3D starts to get a little confusing. So let's try to remember that with the 3D, the X is going this way, the Y is going up and down, and then the Z is coming towards us. So if I want my street to kind of go across the width, then we want to make it bigger in terms of width. And a plane is just one flat surface, so it doesn't actually have a height. So let's try 10 for the X value. For the Y value, let's do, or for the Z value, let's do like 2. And that should be good. So then let's add a material. So we'll say constant street material. I'm going to use mat as an abbreviation for material. New 3 dot, let's use the mesh basic material. And let's give it a color. So we'll say the color, I'll just do black since it's a street. And then we have the mesh itself. So we'll just call that the street. Is a new 3.mesh with the street geometry and the street material. So it is a lot more code just to create one thing, but that thing has a lot more information about it. And so then let's finally add that to the scene. So we'll say scene.add street. So let's take a look at that. Okay, that's nice. One thing that you'll notice right away is that it's not actually flat. Okay, so the plane by default is actually facing towards the front of our scene. So we're gonna need to rotate it over. Also notice that when we rotate around, the street disappears. So that can be tricky, especially if like you loaded it up and you were in the wrong perspective, so you just didn't see it. So again, a way that we can fix that is by adding another argument to our basic material. I'm not sure what that argument is, but I think, okay, we can see here its side is 3.double side. So that's a constant that's part of the 3 library. So let's just put that in just so we don't have to worry about losing our plane. Oh, actually it doesn't really, oh, there we go. Okay, anyway, so we need to actually kind of turn the plane over like this so it's flat. So let's try that. And so the way that we do that is by using rotation. So we can say street.rotation, and we want to rotate it. This is X, and we kind of want to rotate it down. So we actually want to rotate it on the X. So we're going to say .x. And since we're using a circle, rotation goes in a circle, we're going to use pi here. So I'm going to say math.pi times, let's just try 1, see what that looks like. Okay, that looks like it's just rotated around. So let's try with 0.5. Okay, that's a little bit closer to what we want. It actually doesn't really matter if it's up or down since we did the double side, but let's take that out for a second and just check. So it's actually backwards. So that's another thing, is we have to get the rotation in the right direction. So let's try negative 0.5. Okay, so that's like, that looks like that's a 90-degree turn. So we did math.pi times half, 0.5. So that's a 90-degree turn. And so now we have our little street. So that looks good. We can turn the double side back on and do negative again. And I don't really have to use pi here. Like I could just use whatever that number is, 3.14. But by using pi, I know that it's going to be equal to either a full rotation or a half rotation. So that makes the math for this a lot easier. So I'm taking the value of pi and then multiplying it by 0.5 to get half a rotation. So that's our street. Let's make it a little bit longer so it goes across the whole scene. And notice that it's centered. So by default, our geometry is going to be centered and it's going to be drawing from the center. So the origin or the middle of our plane is somewhere like right there. So when we rotate around, you know, it's still going to be right in the middle. So it's a little bit different than P5, where by default, a rectangle is top left and then goes down and over. In three.js, all of the objects draw from the center. So even if it's a plane, if this is the center point, the plane draws around it. Okay, so we have our little road. Let's put like a little sidewalk next to the road. Let's make it a little wider, actually. Make it like 4. Okay, so that's nice and wide. So I'm just gonna make a little street. Let's put a little sidewalk next to it. So we don't actually have a lot that we can do with lighting right now. So let's make the sidewalk just a bunch of boxes. And so for that, I'm gonna want to use a loop. So instead of having to make like a whole bunch of these things, I can just make a loop to draw one in a bunch of different places. So I want to kind of draw a sidewalk just going kind of like down the side of the street on this side. I'm drawing kind of ugly rectangles, but you can see what I'm going for here. So we're just going to go all the way down the side like that. So we'll start over here, and to think about it, we know that our street, like the middle is right here somewhere, and the width of the street is 20. So we know that on X, this is like -10, and then 10 is over here. And so we'll use that for our loop. And we also know that this is like 2 units. So we'll start on the Z at -2. So Z is going positive in this direction, and so we'll go to -2 this way. So it is a little bit harder doing math here because you always have to be thinking about the 3 different dimensions. So I'm going to use X inside my for loop. So I'm going to say let X equals, and then again, we're starting with -10 here. So we'll say -10. And I probably actually should maybe use some variables here. So maybe we'll say like, and we can use, let's use let. I'm trying to think if I should use constant. I can use a constant here because I'm not going to change the width. So let's say the width of the scene is 20. So we'll say the street is the whole width. And then the X, if we want to start on the other side, we'll say negative width divided by 2. So we start on the other side. And then as long as X is less than width over 2. So we're basically saying, if this is a top view of our street, here's 0. So we'll start at -10 and we'll keep going until we get to 10 over here. So width is 20, -10 is 20 divided by 2, and 10 is 20 divided by 2. Let's just do x plus equals 1 to start and see if that looks right. And so we need the geometry, the material, and then the mesh, and then any transformation that we have to do to the rotation or the scale or the position. So let's make our geometry first. So we'll say constant. Since I'm inside of a for loop, I can actually just use geo for geometry here because it's scoped to the for loop and it'll go away after we get out of the for loop. So our geometry will be new 3.box geometry. So it's going to be a box, but we're going to change the spacing a little bit. So let's remember our box geometry. So I'm going to look up box geometry. And so the box geometry goes width, height, depth, X, Y, Z. So that one's pretty simple. So for the width, that's the X. So let's do 1. And then we're going to actually want to make it a little bit smaller than 1 since we're going up by 1 each time. So maybe let's make it like 0.95. Then the height for Y is going to be very small because it's just like a little sidewalk piece. So let's do 0.1. And then for the Z, for the depth, let's do the same thing as X because we want it to be square. And so then for our material, we have new 3.mesh basic material. And let's choose a color. And so for the sidewalk, I probably want something gray. So something like that. And so OX and then our hex value. Then we have our sidewalk block. And so that's a new 3.mesh. We have the geometry and the material. And then we need to change the position. So notice with three.js that the size of our geometry and the position are kind of separate things. Unlike in P5, we still have a position and size, but they go into the same argument, right? We would say like ellipse, X, Y, width, and height. But with 3D geometry, there's a lot more going on. So we treat the size of our geometry and the position separately. So we're going to say sidewalk dot position, and then we can say dot set to set all three. So we can either set one element of the position or rotation by itself using like street.rotation.x or street.position.x. We can also set all three by using the dot set method. The x comes from our loop right here, so we can just leave x. And then for y, we can do 0, or if we really wanted to be specific, we could use half of the height because it is drawing from the half point. So if we want to kind of raise, so like right now, if we were to, if this was like if this was the floor, our sidewalk would kind of look like this. And so this would be in the middle. If we want it to be on top, we would just raise it up half of the height. So if we want to be a little more specific here, we could say 0.05. So 0.05 is half of 0.1. And then for the y, and then for the z value, again, half of the size of our street, which is 2. I guess then we have to actually add plus half of the width of the sidewalk. So let's say plus 0.5, which is just 2.5. So it gets a little tricky, but you can always edit these numbers to move things around. So then we'll say scene.add sidewalk. Okay, so that looks good. I forgot to make the z negative, so let's do negative 2.5. So we've got our sidewalk. That actually looks okay. It's gonna look a lot better when we get our lighting in here. There's a little bit of a gap between the sidewalk and the plane because the sidewalk is a little bit smaller. So let's make this 2.4. Okay, that looks better. And then let's actually just extend the sidewalk below, the street below the sidewalk. So let's make that like 6. Okay, so that kind of looks better. And then, if I wanted to make the sidewalk like twice as big, I could just make like, sidewalk 1 for one side of the row. I don't have to like repeat this whole for loop. And then I could just copy this and paste it and say this is like sidewalk 2. And I can use the same material and geometry because I'm not actually changing anything about them. And I'll just move this a bit farther over on the z-axis. That's a little bit too far. That's not it. -4. That's better. 3.5. Okay, that's pretty close. So it looks good from the top view. Not quite as good from the side. You can see that it's actually kind of like over here on the x because we didn't account for the size of the geometry itself. So we could add that to the x value. We could say x plus 0.5. X plus 0.5. Okay, and that looks a little bit closer, so that's kind of nice. So that looks good enough. Let's extend our street a little bit farther again, just to match up with this. Okay, so that looks good. So there's our sidewalk. Now let's add our buildings. I'm going to use a similar approach here. So I'm going to do a similar for loop. I'm going to use x again. So I'm going to make fewer buildings though. So I'm going to say for let x equals negative width, or sorry, width over 2. And then x is less than width over 2. So I'm just going, you know, from one side of the street to the other, but I'm going to go a little bit farther each time. I'm going to go maybe 4 units each time, so the buildings will take up a little bit more space. And so now I'm going to still use boxes for my geometry, but they're going to be a little bit different. And so I'm going to use some randomness here so the buildings aren't all the same size. And I'm going to start by just creating a height value for the building. So I'm going to say constant h. I'm going to use h as an abbreviation for height here. We don't have the random function anymore like we did in P5. Like there's no random, you know, 0 to 10 or whatever like we have in P5. But we can use math.random. Since we don't have a function to create a random range, what we can do is basically say, you know, what we want the smallest height to be. So let's say we want, you know, the buildings all to be at least 10 units high. Let's say this is 10. And let's say, you know, they could be somewhere between here, here, and like here. So we could say, you know, the most you can add is like maybe another 10. Maybe this is 10, and the least obviously is just going to be 0. So what we can do is we can say 10 is kind of the minimum plus math.random times 10. So this part is going to give us a random value between 0 and 10, and this part is just going to be 10. And so we add them together, it'll be something between 10 and 20. So we'll use that as the height for our geometry, constant geometry, and so we'll say new 3 dot box geometry. And so for the width here, let's say 3.5. So it'll be smaller than 4. And then for the height, we'll use h. Doesn't really matter that much here. I guess we want our buildings to kind of be a little bit longer than they are wide. So maybe we'll say 5 there. We can adjust that later if we want. So for the material, buildings obviously are not just one color, but for now we're working with kind of simple stuff. So we'll do a mesh basic material, and I'll just use maybe something that'll stand out from the blue. So maybe let's use like an orange color since we have that blue background. Let's try something like that, see how that looks. We can always change it later. So we have the geometry, the material. So let's make our building. So that's going to be another mesh, 3.mesh. Put in the geometry, put in the material. Now we're going to have to move it around. So of course we're going to start with the position for the x. So we'll say building.position.set. So for the x, we're going to again get x from our for loop. We're also going to add to it a little bit since we are drawing from the middle. So we'll use this 3.5 and we'll do half of that, which would be 7.5. Let's actually make a variable here so I don't have to calculate that if I want to change it. So we'll say the width is 3.5. We can change that if we need to. So then the width of our box is w, and then we can use w over 2 for the starting position on x. The starting position on y, again, we're drawing from the middle, so we have to add half the height to start. So y is going to be height over 2. That should be pretty simple. And then for the z, we're going to have to move it even farther than where the sidewalk starts. So let's start with -5, and then we'll move it around there because we changed the sidewalk a bit. So then just say scene.add building. Okay, so our buildings are way too big unless we're like in Manhattan with a bunch of skyscrapers. So let's adjust that a little bit. We also need to move it a little bit this way. So let's make our baseline for our buildings like 5. They're still quite large. Okay, so maybe we'll make it 4, and the random will make it 4. Because I guess our street is only 20 units, so that looks a little bit better. That makes more sense. And let's move our buildings back just a little bit. So let's try -10. That was too far. Try -8. Still too far. -6. It's a little bit too close. 6.5. Okay, that looks perfect. Of course, you know, eventually I could put in like some windows and some doors and stuff the same way, but for now, I'm just gonna leave that as is. I see that the buildings did not, however, take the color, and that's because I can't actually just add a color like this. That's my mistake. So let's add in our parameters. So we want to say that that's a color, and then there's our color. So there we go. That looks better. And so let's actually move our camera back a bit so we can see our scene better. So we originally set the camera position at Z is 5 and Y is 5, but if we increase these values to like 8 and 8, we'll be a little bit farther away, a little bit higher. Maybe I don't actually want to go higher, but just farther away. So let's try 10. Okay, that's pretty good. Maybe we'll go up just 1 unit. And the nice thing with the orbit controls is that even though we change the camera, it still does all these calculations for us, so we don't have to worry too much about that. The orange is pretty bright there, so let's maybe keep the same hue, but bring it down a bit. Maybe right there. That looks okay. We're not really going for realism at this point, so we just have some different buildings. Okay, so now let's add in some trees, and then I think we'll be good. So let's add some trees in here. And I'm gonna do these trees a little bit differently than the other elements. So I am gonna use a for loop, but I'm not gonna base it on the X position. I'm just gonna base it on the number of trees that I want. So I'm gonna get that number first. So I'm gonna say constant num trees, and we'll set that randomly again. So I'll say, let's say the lowest number of trees is 5. The highest number of trees is, let's say 5. So that will give us a range between 5 and 10. So then I'll say for let I equals 0. So I'm counting using I now instead of X. I is less than the number of trees. I++. And so we're actually going to make a group for these trees because we want to kind of move the group and scale and do different things with the group. So we can, by using a group, we can make changes to the whole group by itself rather than just to each individual piece of geometry or each mesh. So I'm going to start with a group. So I'm going to say constant tree equals new 3.group. And so a group is just what it sounds like. It's a group of objects that we can move their position, we can change their scale. So that way I don't have to change the position and scale of each individual part of the group. So to start with our tree, let's make the trunk. So the trunk is going to be kind of a cylinder. If we add a cylinder in the editor, just to take a look at what it looks like, there's a default cylinder. So we're obviously going to have to make the height a lot taller for a tree. Might want to make the radius of the top a little bit smaller than the bottom. Just a little bit, not too crazy. You know, that's pretty good. We might use like a few more radial segments if we want to make more detail, but I think that should be fine. So our geometry is going to be cylinder. So I'll say constant geometry is a new 3.cylinder geometry. Okay, and so let's look up our cylinder geometry. So we have the radius of the top first, radius of the bottom second, the height, and then the number of segments. So the radius at the top, let's do something kind of small, 0.25. And the radius at the bottom, let's say 0.5. So that'll be kind of small as well. We don't want the trees obviously to be the same size as a block on the sidewalk. And then for the height, we can use a random number here. Now I'm thinking, okay, I'm gonna use this randomness again. And this is the third time I wanna use like a random range. Now I'm starting to think, maybe that P5 function was actually useful. Maybe we should make our own random function. I'm actually just gonna Google how to do this, but let's do a random range function here. So let's just Google this, JavaScript random range. And I'm going to the second thing because math.random, I know what that is. That's just a description of this. Generating random numbers in JavaScript in a specific range is pretty much exactly what I want to do. Turns a random number between min and max. Okay, so that looks pretty good. And then we have a return a random int, which is actually not really what I want because I do want more variation than just the whole numbers. And there's actually a very nice explanation of how this works, which is very cool. But this looks reasonable to me. So it's basically taking a min value, a max value, subtract the min from the max, multiply by random, add the min. So that's pretty close to what we already had, except it's just taking into account the possibility for negative numbers, essentially. So let's grab this and paste it. And I'm just going to change the name to random. I don't need this long function name, but let's add a link here to where we got it so we can go back and see it if we need to. And so now let's change these. So instead of 4 plus 4, we're just basically saying random between 4 and 8. So we'll say random between 4 and 8. And where else did I use random? Oh, right here with math with the number of trees. So now that's random from 5 to 10. So let's reload it and see if it worked first. No, I got an error, 52. Oh, because I haven't finished my tree geometry. Okay, so that still works for the rest of the scene. So that random function seems to be working fine. Okay, so now let's do our tree height. And I'm going to save this as a variable because I'm probably going to need to use it for other stuff. So let's say constant h for height. And let's say it's random. For the tree, if the buildings are between 4 and 8, let's make our trees like 2 to 5. We can always change this later. And I guess now it's, do I use the same syntax? So this should actually be min, max. I guess this would be min minus max, just to match the three.js syntax. Not necessary, but if you want everything to look consistent, that should be good. So for our cylinder, we have the top radius, bottom radius, height, and the number of details. Let's do 5 for now. I think that'll be fine. Then we have a material. So let's choose, since it's the tree trunk, let's do some kind of brown material. Maybe light brown, that's kind of nice. So new 3.mesh basic material. Color is 0x and the hash. And then we have our trunk. So let's say constant trunk equals new 3.mesh geometry and material. And then tree.add trunk. Okay, so let's go ahead and add the tree to our scene. So we add the trunk to the tree. We add the tree to the scene. So we'll say scene.add tree. Somewhere I put a colon. What line is that? 51. Oh, right here. Okay, so there's our tree trunk. That's a little bit bigger than what I actually want. So let's make this even a bit smaller. Let's say 0.125 and 0.25. Okay, that looks pretty good. And the height is actually very tall. At least the height of one of them is pretty tall because we are going to move this up a bit. So let's do 2 to 4 here. Okay, that looks pretty good. Now we can use the X. So we're gonna say, before we add the tree, or actually it doesn't really matter, but we'll just say tree.position.set. So let's make the X value. So it's just gonna be a random value. So we'll say random, and so we'll say negative width over 2 to width over 2. For the X value. For the Y value, it's height over 2 or H over 2. So this is a little confusing, but the scene width is width and the tree height is H. Maybe I should change width to scene width. That makes it a little bit easier to understand what's happening here. So I'll just replace these guys. I guess it's really the street width because the scene goes beyond that, but that's fine. Okay, so there's our trees spaced out. That looks nice. Don't want them in the middle of the road, so let's change their Z position as well. So after height over 2, let's say the Z, it could be like anywhere in here. So let's say random from -2, I think, to -4. Let's see if that looks right for the Z. And so this is a little confusing because I am just writing directly in here. So let's bring these out. So let's say let X, because we are actually using stuff for each one of the position values here. So we'll say let X, let Y, or actually Y is fine. Height, we can just use H over 2. That is pretty self-explanatory. So then for Z, we'll use random -2 to -4. And so then we'll just use X and Z. Oops, I said Y instead of Z. Okay, that looks pretty good. It is kind of random, so sometimes the trees are going to be a little close to each other. There are different ways that you could kind of distribute them. That's getting a little close to the edge, so let's say -3. Okay, that looks kind of better. So let's maybe make fewer trees just so I don't see as many issues with that. Let's do 4 to 8 trees. And I'm just going to kind of ignore that they're like sticking out of the sidewalk for now, because we don't really see that from here. So now we are going to add some leaves, and I'm actually just going to add a bunch of spheres just to kind of make it look a little stylized. So we're going to make, again, a bunch of spheres. So I'm going to do another loop inside of my tree loop. So I'm going to say constant num leaves. They're not really going to look like leaves, but let's say random like 10 to 20. And let's do a loop. So for let, we can't use I again, so let's use J equals 0. J is less than num leaves, J++. Okay, and so for our leaves, we're gonna just make a sphere. So let's look up our sphere geometry. Okay, so we have the radius, which is the size, width segments, height segments. Actually, let's look up at a icosahedron. Okay, this is also used to create a sphere, but not using width and height. So I kind of like this better for what I'm about to make. We can make kind of like a low poly tree. So it looks like the default detail of 0, fine for this, and then the radius is just how big it is. So that's actually a lot simpler to deal with. So that is the icosahedron geometry, kind of a long name. So the constant geometry, actually we can't use constant again because this loop, this geo will still exist inside here. So let's just use leaf geometry is new 3 dot, let's paste that in, whoops. So let's just paste this in because it's kind of long. And let's just do a random size, random at 0.5, or that's actually pretty big. Let's say 0.25 to 0.5. And then we'll do the leaf material is new 3 dot mesh basic material. And we have a color, which is, let's choose a green color for that one. So let's go to the greens, choose something nice there. And then let's make our mesh. So we'll say constant leaf equals new 3 dot mesh. And the mesh gets the leaf geometry and the leaf material. And then let's add a little bit of randomness to the leaf. And one thing that I want you to notice here, so what I'm going to do first is say tree.add leaf. Notice that even though I haven't changed the positions at all, that the leaves actually follow the trees. Since the leaf is part of the tree, it takes on the tree position. So any position that I add to the leaf is going to be relative to the tree itself. So if I move the leaf over on X, if I say leaf.position.add, if I move over on X, so I'll say, or sorry, position.set, if I move over one on X, they're going to be 1 over from the tree. So I can actually kind of start over again at 0, 0. So let's say, we got to move it up to match the height of the tree. So we can go up h over 2 since the 0 is in the middle of the tree. So for height, we'll say h over 2. And then what I want to do is, since I have so many leaves, is just add a little bit of randomness here. So I'm going to say let x equals random. Let's actually use negative here, so negative 0.25, otherwise they'll all go in the same direction. And I'm going to use the same thing for z. And let's actually add a little bit of randomness on the y as well, so they're not just kind of all in the same place. And so I'll say x for x, h over 2 plus y for the y value. Or I suppose we could just put the h over 2 here. And so that's our full y value. And then the z. Okay, so we can get these kind of like clusters. That actually doesn't look that bad. Let's increase the randomness a bit more though. At least on the x and z, maybe not so much on the y. Okay, that looks kind of cool. One thing is that the geometries are all the same. And because it's an icosahedron, they're kind of all the same, but we can actually add some rotation as well to make this a little more interesting. So if I go in here and set some rotation, I could say leaf.rotation.x equals random, let's say 0 to math.pi times 0.5. And I'm only going to do this on 2 axes because if I'm rotating on 3 axes, they end up kind of canceling each other out, which is a little bit complicated to explain, at least for now. So I'm just going to say leaf.rotation.x equals random, leaf.rotation.z. Actually, let's just use y here and give that a random value. Oh, and I spelled rotation wrong. Okay, so it's a subtle difference, but you can see they're not kind of all facing the same direction, which kind of gives them the same quality. And actually, let's move them down a bit on the y. So let's actually make this like negative 0.5 in the other direction. So those actually kind of look like nice little trees. They're kind of funny. We're still not using any lighting, which is why everything is kind of flat looking, which you might like. That might be like a good look for you, but that looks pretty good. We could kind of make the trees bigger if you wanted to. You could like actually set this randomness. Oh, why do I have, oh, the detail. I don't want this here for the detail. There we go. Okay, so that's a little bit, that's actually pretty good as far as our trees. And part of the reason that we see a lot of detail there is because we are using so many of these icosahedrons. If I just had like a couple, you know, there's still get that same basic idea. So you might like that look better. But the more we add, the more kind of randomness is, the more detail there is. So that's pretty cool. I'm pretty happy with that as far as my scene goes. So let's stop there for a moment. So if we're using code, we get a lot of advantages. We can use loops, we can use randomness. There's a lot of stuff we can do to kind of add more elements to the scene without actually having to place each building in place. However, if you do want to do that, you can still do it with code, just going like one at a time.